For those of you who didn't hear my intro, I'm Joe Field with Salt Creek Technologies. We're manufacturers rep out of the Illinois area, but we work in Wisconsin and Indiana as well. We're focused entirely on industrial wastewater treatment equipment. We don't work municipally and we don't work with rotating equipment. So big treatment systems, DAFs, clarifiers, ROs, UFs, things like that. So that's just kind of who we are, and this presentation is going to be mostly focused on the various technologies. We've already kind of gone over the different categories. I'm going to dive a little bit more into the variations of the types of DAFs that you can run into, the types of aeration systems you can run into. So that's just kind of an overview. John kind of alluded to this, but I wanted to just kind of use this as kind of my starting point. This is like a 30,000 foot view that I take of how wastewater treatment systems are set up. You split them, primary and secondary treatments. Primary being large solids removal. So get the trees, get any solids you can, strain those out. Chemical treatment, so get the wastewater prepared for your next step, which is your liquid solid separation. There's a lot of different ways that you can set up these systems to do that. After you've gone through the primary setup, then you want to move into secondary, and that's most typically a biological oxidation step of some sort, and then a polishing disinfection step. Now, more and more these days, people are starting to talk about reuse systems and things like that. So that kind of is a additional step that you do to bring the water back to the front of the plant. My focus today is going to be primarily on the primary portion of the wastewater treatment process, just because I think that's there's a lot more variation as far as the equipment technology that you select. But we will touch on biological as well and the various technologies that are employed. So just kind of what primary is. Like I said, primary is mostly industrial facilities. That's where you run into it. Most industrial facilities have a primary treatment system, if they have a treatment system at all. It's there to meet your statutory limits. So your metals requirements, your FOG requirements, and things like that. And that's usually the largest driver of why you have a primary treatment system. It's there to remove solids prior to secondary. So if you do have a secondary, it's a good way to get it set up to work well. Primary systems usually are smaller. They have lower energy requirements. They're in general, I'm going to famous last words, but they're generally easier to run in some ways, or they have less attention on them in a lot of ways. And they can be there helpful in lowering surcharges. Now, we'll talk about this in a little bit later, but a lot of times lowering surcharges is not enough of a driver for a primary treatment project. And finally, the way I like to look at a primary system is it's going to make what's coming out of your industrial facility look like what might come out of a home. Okay, so if you want to get rid of the metals, you're not at your house dumping entire gallons of oil down the drain and things like that. So you just want it to get to a lower FOG, lower metals concentration, in some cases a lower BOD concentration, depending on where you're discharging to. On the secondary side, you're typically, your facility, if you have one, you're going to be a direct discharger. There are some cases where you might still direct discharge to a municipality, but rarely is that actually the case. It's there to reduce your BOD, COD, larger footprint, higher energy costs, usually with the aeration systems and things like that. So let's dive into primary treatment first, starting with the first one, large solids removal. This is almost always your biggest bang for your buck. You are going to really be able to get a lot of solids out of the system. You're typically not chemically treating, so you're avoiding that cost in some ways. But usually these are solids that are already there, and it's easy to do. You want to put this though before your EQ tank, before your chemical addition, before your treatment. You want it really before everything, and as close as possible to the source of the wastewater that you're generating. Reason being is you don't want solids getting in pumps. You don't want those solids to be settling out in your EQ tank where they then can start to break down, release soluble BOD, and start causing other issues. With screens, the first thing that you want to think about when you're selecting a screen or sizing a screen is flow rate. We run into a lot of problems with this actually. I think it'd be pretty simple, but it's not the flow rate that's your average flow that you're getting through your system. When we're sizing a screen, I don't want to hear how many it's putting through in a day. That's not useful for a screen. You want to know what your peak flow is. So say during CIP, the first 10 minutes you have both sumps kick on and you for 20 minutes you have 500 gallons. That's the important thing you need to know for a screen. That's really important if you like having your wastewater treatment room be fairly clean. Otherwise, that 10 minutes you're going to overwhelm the screen and you'll flood it out and end up with water all over the ground. The other important things are the amounts of solids, the size of solids, and the type of solids. So it's a really sticky solid. It's not going to convey well in the screen. If it's a solid that has weird angles or stringy, it can get through the wedge wire and hang up, and then you're stuck with it, stuck in the system. So that's an important thing too, and it's a pretty easy test to see how that is going to work. You just get a piece of wedge wire, run it over, see how the solids kind of come out. And applications wise, screens are everywhere. They're a really good and effective way of treating or removing large solids. So I'm not going to go into detail about every single one of these, but what I want to point out is there's a whole slew of different types of screens that you can run into. There's bar screens that have really large openings. They're there to remove big pieces of debris. And then you have fine screens that have much smaller openings in the range of millimeters or thousands of inches. So it's a very wide range as far as what slot opening you have in the screen. So a disclaimer on these charts that I'm going to put up here, these stoplight charts. This is by no means, if it's red, you should never put it in the system, or if it's green, don't even think about it, just do it. But I think it's a good way to start a conversation and a good way to kind of think about how people approach this when they're selecting different technologies. So the major takeaways here, in my opinion, a bar screen, if you have very large objects in your wastewater, you're treating a very high flow, and you want to, and it's a gravity flow usually, great application. Fine screen, it's not as good at removing, if you don't want to try and capture a glove in your fine screen. It will capture it, but it might cause other problems down the line. It's going to be better at TSS reductions, smaller slots, it's going to capture more solids, and they can handle pumped flows the way they're designed and set up. So those are kind of just some things to think about. And a band screen usually falls somewhere in the middle as far as what you're trying to do. So next one, we'll just go quickly over chemical treatment. We've already talked a lot about chemical treatment. I'm just going to talk about the two most common types of chemical treatment that you run into, or at least that we see in industrial applications. That's the pipe flocculator type systems. So that's purely relying on the energy of the water flowing through the system to mix your wastewater and your chemistry that you're adding. The one on the top there is your flow through reaction system. So this would have mixers installed on the top. They're actually there actively mixing the system. And like we've been talking about, they can be there to do pH adjustment. They can be there to add coagulant. They can be there to do precipitation. There's a lot of different types of applications that you can use here. Things that you want to be thinking about, though, when you select these is the type of mixing energy. So we've talked a little bit about that. You don't want your mixing energy. In some cases, you want it to be really strong. So when you're coagulating something, you want a good, strong mixing energy. But when you're flocculating, you want it to be more gentle. That's one of the benefits of a tank system. You can have a little bit more flexibility as far as I'm going to have a high-speed mixer in the front end to put a lot of mixing energy into the system. I can size that tank to have a slightly larger or smaller residence time. So if I have a really long reaction that takes a while to happen, I can make a much bigger tank and let that mixing happen for a while, let those reactions go to completion. Pipe flocculator is just less flexible that way. You can put them in series, you can do things like that, but most of the time you're still really restricted by what the pipe flocculator can do. Now I say that, but I've installed a lot of pipe flocculators because they are very good in applications where you don't need a long mixing time. So food industry, dairy is really good about that. But, you know, metal treatments and things like that, a lot of times you're running into the tank reaction systems. The other thing you want to think about is turn down. So I kind of mentioned that, but a pipe flocculator is designed for a very specific area as far as what flows you can deal with. Whereas a tank reactor has a lot more flexibility in terms of what you're selecting. Again, pretty much any wastewater treatment system you're going to run into, you'll run into these chemical treatment systems. I think I touched on most of these things. I guess the only one I didn't really talk about is a tank system can be, if it's not designed, and Chris alluded to this a little bit with making sure you have injection points in all the right places. You want to be sure that you're not short-circuiting. A tank system can be a little bit more, has more potential to have that happen, whereas pipe flocculator a lot of times is you can't really put it in the wrong place. So yeah, footprint is probably the last thing that I didn't really mention, but pipe flocculators a lot of times have a lot smaller footprints. You can do it in a lot smaller areas. So that's another reason why food plants a lot of times have it, because they just don't have space to deal with it. So before I go to that, any questions on screens or chemical treatment systems? And I'll ask questions. So I think we've gone through most of the objectives of the separation processes, so we'll skip over that for the most part. But like we said, non-dissolved portion of the wastewater is what we're trying to remove in your primary treatment separation process. When you're picking what separation process, you want to think about how do the solids settle after you've generated your nice flock. Is it confused? Does it not know whether it's floating or sinking? Is it not? Does it sink really fast? Does it float? Those are all things that you want to think about. Emulsions, we've talked about. Treatment requirements, as far as what you're trying to do, you want to think about that too. Are you looking for a really, really clean effluent, or are you looking for just a fairly clean effluent? Those are all considerations you want to have when you're selecting. The first, and typically it's one of the first steps in most treatment processes in oil water separator, if you need it. It's there to remove free dispersed oils. Dispersed oils being like down to 10 to 20 micron or so. Emulsified oils are the ones that are smaller. The droplets, that size that is. These systems are designed to remove that size of a droplet specifically. So you might say, okay, I'm going to remove. You're doing it just as a scalping operation, so you might be able to squeeze a smaller one into a footprint, but you're not going to get as good of a free oil removal. And so you need to think about the flows that you're doing and also the amount of oil that's coming into the system. As far as different designs of the actual oil water separators, the two major ones that you run into are API, or the open style oil water separator. So that'll have just an open tank, much like a clarifier. It's just an open tank for the oil to flow to the top and everything else to flow through. Or a coalescing system, which is the diagram we have right here. And that's going to flow through a pack. That pack is going to help the oil droplets accumulate, form larger droplets, and flow to the top more rapidly. Essentially, all the coalescing filter is doing is letting you put more flow through the oil water separator in a smaller footprint. The only problem with them is it is a coalescing pack. You need to think about, do I have solids? Is my oil that I'm treating there, is it sticky? Is it going to build up? Is it going to cause problems? I've seen instances where these oil water separators are coalescing and get so much oil built up on them, they actually start just floating. So, you know, it's definitely something you want to consider. And then also the amount of solids that you have. Coalescing, just because of the sheer size, sheer fact that they're smaller, you want to make sure that you don't have a lot of solids, because they're just not going to be able to handle as much solids. Here's a list of just kind of applications that you've seen a lot in refineries, steel mills, general manufacturing, really anywhere that you can get oil on water. You really see them everywhere. Clarifiers we've already talked a lot about. So the big thing though, the big difference between the two is your conventional, which is your circular clarifier, wide open system, just a big spot in the line for things to drop out, and inclined plate or lamella clarifier. Inclined plate lamella clarifiers are great because you're reducing the amount of footprint that you have for a given flow rate. But again, you need to be careful, because if you're trying to put too much solids into a unit, you can really end up with a clarifier that's slammed full of solids, or you'll end up with a dilute or a sludge that's really dilute. So you want to make sure that when you're picking a lamella, you make sure that you're going through the calculations that it's going to settle properly. You're going to develop a sludge that's thick enough that you want it to actually be able to then be a sludge and not just another 50% of the stream going through the unit. I don't even think there's an industry that doesn't use clarifiers. Really, at this point, there's very few. They're used in municipalities, they're used in mining, they're used in power generation. Really, anywhere and everywhere they can be installed.
So I have a question.
Yeah.
Oh, maybe you're gonna. Well, that's a DAF.
Yeah.
In the lamella style clarifiers, what are your thoughts on maintaining a sludge bed, somewhat of a sludge bed in the hopper in the bottom? I've had people say both ways. They think you should, or you should completely evacuate.
Yeah. So I think it depends really on the design of the lamella you have.
Sure.
So this style here, where it's got a large hopper on the bottom, I'm fine keeping a fairly good size sludge blanket in the bottom. So a lot of systems, this one doesn't, but a lot of systems will actually have an auger there to help, because what's happening while it's sitting there is it's also compacting. So it's dewatering and thickening more. Some of them will actually have an auger or some sort of device that's rotating in the bottom to allow water to get freed out of that sludge and come back out. So you get a thicker sludge if you leave it in there. Now, you don't want it to the point where it's reaching the top of the plates or something like that, sure, obviously, because it's not going to be clarifying anymore. But in general, I'm okay with leaving a fairly decent, sludge bed, maybe a foot or so. It's okay, depending on the geometry of the system, sure, obviously. Any other questions on clarifiers? So DAFs, these are, like we've said, good at removing suspended solids, really good for high FOG applications. You're using air to float or nitrogen in some cases. So on anaerobic digesters, for one, because that liquid that you're trying to clarify is a lot of times has still some residual methane in it. A lot of times you'll use a nitrogen DAF instead. There's other ones that'll actually use the same gas that's coming off the unit, but that's also in refineries and other places where they have a really high oil concentration or flammable gases, they'll also use a nitrogen system. I think we've talked through most of this. The big difference between the various DAFs that are out there are open style units, so units that have no plate pack in them, and plate pack units. Again, that's doing almost the exact same things what a lamella clarifier is doing. So if you think about when they took that little device and tilted it on its side, how much quicker same principle works for it floating as well. So the solids will hit those plates and shoot right up to the top much faster than they would if they were just floating on their own. So you're able to put a lot more flow through a given footprint with the plate pack versus the open style. Thing you need to watch out for, again, like the same thing with the incline plate clarifier, is if you have too many solids, you're going to overwhelm DAF, and your DAF is not going to be able to physically remove the solids from the top fast enough, and that sludge layer that's built up right there is just going to keep growing and growing and growing downwards until it gets sucked out. Yeah. So you just want to make sure that you are able to balance those two things with these higher rate systems. So, and applications, big ones for DAFs, food, both in the primary and the slaughter industry and secondary processing and tertiary further processing industries. Dairies, pulp and paper, anaerobic treatment. Really, again, they're becoming more and more prevalent in more and more places just because they have a smaller footprint and generate a nice clean effluent. So, ultrafiltration, this is maybe not as popular of a conversation here, but it is a technology or membranes as far as their performance. They are very good at dealing with emulsified oils. They are also very good at removing suspended solids. They are a physical barrier, so you're pushing the water through a hole that's 0.02 micron in size. So any oil is going to be retained and any solids are going to be retained for the most part. Soluble portions of the wastewater are not going to be retained though. So that's important. You're not going to get soluble BOD reduction. You're not going to get metals reduction unless if you've already precipitated out those metals. So that's a thing we get asked a lot is I want to reduce chlorides and I want to put in ultrafiltrants. You're not going to succeed with that. This unit is called a tubular ultrafilter. So the tubes are about 1 inch in diameter. They are really good at handling high solids, high oil and grease, produce a really nice clear effluent. They can handle these high concentration factors. So you can, because they're able to be cleaned pretty aggressively and they have a wide opening, so you don't have anything that's going to plug off physically that easily. The other type of ultrafiltration that you run into a lot is hollow fiber. Hollow fiber ultrafiltration looks like a stack of straws packed into a pressure vessel. Great on the water side. And can be good on the tertiary, like if you're trying to just do a polishing step on the back end of your wastewater treatment system. Not so great for primary application. You really don't want to try and do much with hollow fiber at that step because you're going to end up with a packed full membrane that's useless within a fairly quick time frame. Applications, centralized waste treaters, machining, fabrication. We do see some of these in the food and beverage industry sometimes, but it has to be pretty good application and usually generally pretty small flows. And then we talked a little bit about this. MBRs are using the same type of membranes as these. So it's ultrafiltration, not specifically these 1 inch membranes, but they're still using the same membrane material to do the same thing. So just kind of another way to look at everything. If you have a high fog stream, you probably want to stay away from a clarifier because it's going to float and you're not going to get really good performance out of it. If you have a strong emulsion, maybe it's time to think about a UF system. And then energy requirements, we already kind of touched on that, but there is a pretty wide range as far as how much energy you need to put into a system to make it function properly. So I think it's always easier to talk about actual applications and examples and go through it that way. So The first one I wanted to talk about is a food manufacturer. They are cooking chicken, lamb, and beef. It also, which was interesting about it, it had a bakery section as well. It had sauces and marinades portion. They were making dipping sauce. I mean, they had everything in the plant. They do have everything in the plant. So it made a pretty challenging wastewater stream to treat. Had fairly high FOGs, and then also had variable loading. So through the week, they might be making a bakery item one day and then a sauce and marinade the next day. And they're always cooking beef and chicken, so you have everything kind of coming down the line. And they had a really high peak flow. So one of their sauce lines, when it went through a CIP, the flow jumped from, I think on average it was about 100 GPM up to 600 GPM for a period of time. What made that interesting was sizing of the screen. We came in and did a full, complete primary treatment system for them. And the screen was the interesting part, or one of the interesting parts, because they didn't have a lot of footprint. You can see that's the entire building we had to work with. When we started up when we did the install, we actually had a rental system on the left side there to actually do the processing while we were doing the installation. So we didn't have a lot of footprint. So we wanted to go with a screen still because they had vegetables and other things coming down the line. So we went with an externally fed rotary drum screen. The reason we did that rather than an internally fed is that they have a built-in overflow. So during those once a week super high peak flows, we're actually allowing that wastewater to overflow and go right into the EQ tank. What that did is it's not ideal, right? We're getting solids into the EQ tank, but it kept our system in a manageable location. We were able to build everything within the existing footprint they had without having to do it. Again, the solids loading was actually not super high, so we were able to do high rate DAF, and then we were also able to do a PFR system because we installed enough EQ tank up front that the flow through the DAF was fairly balanced. So the PFR would keep it a fairly constant flow rate. And that's the pipe flow reactor. Makes it chemical treatment system. So any questions on this one or anything jump out? No.
Just that that's a very strange facility that does all of that.
Yes.
I've never heard of that before.
Yes, it's an interesting one. So this next one was a capacity expansion, pretty straightforward. You've already seen this picture. It was an industrial facility. They were looking to expand the capacity in their treatment system, but they didn't have any additional footprint to deal with. They couldn't give us any space. They didn't want to build anything new. And they had a wide range of flows, and the contaminant concentrations went up and down quite a bit. This waste treatment plant was being fed by a lagoon, so in the spring they had some snow melt and rain and things like that, so they had high flows, but then that diluted down the concentration. So what we ended up doing was, because we didn't have much space, was we went with an incline plate clarifier. Because the solids loading was low enough that we were able to do that. And then we went with the tank treatment system because pipe flocculation, the reactions that we were doing took some time. So we wanted to have enough residence time in there to actually get everything done to completion. And two, the flow variations were high enough that you couldn't really effectively design anything else. Went through the exercise of looking at doing a complete expansion or a complete replacement versus just an expansion as well. Part of their thoughts were that maybe they should look at a solids contact clarifier. So we alluded to this a little bit of taking some of that sludge back to the front of the plant to try and help give more opportunities for those particles to form larger particles so that you can actually get better treatment. So we took a look at all those things. ultimately came to the decision that the best way to go was still just the inclined plate clarifier in the building, because you were able to still maintain quite a bit of space. On the left there, you can see what the actual plant looks like as far as additional space, and on the right's the new clarifier we installed, or it's being installed there.
That's a big one.
Yeah, it's I want to say 2,000 GPM.
Oh, wow.
So this one was for a cheese and yogurt plant that they had actually just installed a brand new wastewater treatment system. And so part of the problem they were running into is on that DAF that they had installed, they were getting solids build up in the DAF. This style DAF had a cyclone system that was plugging up with the solids that were coming in. So they were having to take the unit down every day, pull out the orifices that were in the cyclones, clean those up, and then bring the system back on. It was getting to the point where it started to affect production. No one's really happy when that happens. They called us in, and while I would have loved to have actually replaced the DAF that was there, that would have been a quick meeting if that would have been my proposal. We ended up just deciding to install an externally fed rotary drum screen to remove the solids before they hit the primary treatment system. And really what that ended up doing was it gave them enough time in terms of their treatment process that they could go a full week till when they were ready to just do their normal cleaning of the DAF without having to shut down every day and do this annoying cleaning all the time. So it's simple installation, really, not too much to it, pretty low cost as far as everything goes, but does have a big impact on operations and overall performance of the system. Last one we'll do on primary treatment. This was for a rendering facility. Again, they had an existing treatment plant. They had expanded the upstream plant over and over and over again. It had gotten much larger, and they had never taken a look at the wastewater treatment plant. Sounds probably familiar to some people. So they've come to the decision that, okay, we need to do something at this point because our wastewater treatment plant is reaching its capacity for certain. We went through a number of different options with them. We looked at doing a larger primary DAF to try and remove more solids. Before it went into the biological treatment step, we went and looked at just making a larger biological treatment system. And then we came up with one solution to actually do some FOG recovery at the rendering facility, at the rendering plant specifically. What was interesting about this was it's an internally fed rotary drum screen and a DAF. That's not too exciting, but we were able to get a pretty good recovery off of the DAF still of FOG without doing any chemical treatment. What that means is then they're able to get move that material that they're recovering up the value chain, able to get higher resale values on it, and then that also in turn unloaded the wastewater treatment plant. So it was a smaller DAF, smallest capital cost option that we took a look at, but still had a really nice impact on the overall operation.
So is that the DAF whip on top there?
Yeah, so it's an interesting style because they had a pit. We wanted a gravity flow though, and we just went with the setup where it was elevated like that so that they didn't have to put any sort of catwalk around it or anything like that. Unique, but what we ended up going with for that one. What they wanted. All right. So sludge handling, we've already talked quite a bit about this, so I won't go into a great level of detail other than I think two of the big things is you're looking to reduce the hauling costs and disposal costs, and then you're also looking at generating co-products. That's another big item for sludge treatment. When you're thinking about what you're actually looking to try and consider for selecting your sludge treatment systems, it's sludge characteristics that will drive almost entirely the selection of the actual treatment process. So whether you're going to use a screw press, a belt press, centrifuge, whatever, a filter press. There's a lot of different options out there. And that, I mean, those are used still today and important. And I know of one place that has tried a few other things and none of them worked, and now they're getting a rotary vacuum thrown pre-coat system. Things you want to think about, though, on top of that are target residual moisture, filtrate quality. Are you looking to put the filtrate back at the front of the plant? Or are you looking at keeping it in or discharging it directly? All those things kind of need to be thought about with those. And I'll just, this is, because we haven't brought this one up at all, this is a horizontal belt filter. I don't know if anyone's familiar with these or seen these. They're used at power plants a lot on their FGD. So if you've ever driven by a big coal-fired power plant, they have the big plumes of smoke coming up. That's the FGD systems. They generate gypsum off of these, off of that. So this is how they dry the gypsum. Interesting, different sludge handling system than
so it's just a big long.
It's a big long vacuum table.
Okay.
So it gets distributed there at the end and gets drawn over and into the sludge hopper. Or I'm standing right at the sludge hopper right there. At that point,
is it a continuous media or is that disposable?
It's a belt. So it's just like a belt press where it's just a continuous belt going around, and it's got a vacuum on the bottom.
Never seen one of those before.
Yeah. Fairly interesting process. So I just chose these three because if I'm selecting a sludge technology, sludge dewatering technology, these are the first three I think about typically. Screw press is I think also another one. I just don't run into that as much in industrial applications personally. Common applications that work out well, I think, filter press, metal hydroxide, water treatment, water softening plants, things like that. Centrifuges, they're good for activated sludge, meat processing, also heavily used in the grain processing industry. Again, that's a pretty sticky, oily process that needs, a fairly aggressive way of dewatering, I'd say. And then belt press is common pretty much everywhere. So again, I'm just going to go into some application examples. So the first one, this was a plant that it was a cosmetics facility. They made shampoo, hairspray. The existing plant was pretty interesting because they took their wastewater directly out to an aeration basin with no primary treatment, nothing like that. And the aeration basin was partially treating the BOD at best. Really, it had been a pretty well neglected system for quite some time. That aeration basin had MLSSs up around 2,000 milligrams per liter. It was. I'll spare you the details. It was a mess at that point. We got called in actually for a opportunity to have a rental system there. So we installed, and you can see just the corner of it, open style DAF to treat the biological, what was coming off the aeration basin. So we were actually lifting mostly primary solids and some biological material off of that. And then that sludge, it was generating a ton of sludge, as you can imagine, 2,000 milligrams per liter of solids in the basin. That sludge, we then realized very quickly the hauling costs for that were going to be just astronomical. So again, quickly got a belt press brought out there and installed that, and we're able to reduce the hauling cost of that belt press pretty significantly, or the sludge pretty significantly, and then just generated a nice, easily disposable waste at that point. Initially, that belt press was running 24/7 for about 6 months while we were going through and cleaning up that system. I think in that time alone, we ended up paying for the entire purchase price of the belt press and the avoided hauling costs. And now it's running probably once or twice a week on a much more infrequent basis. The DAF is a little bit less loaded, but still providing what needs to happen. So it's just, you know, I think it's illustrative of how important considering hauling costs are of sludge, especially when you're dealing with just a DAF. A lot of plants will just take a DAF sludge and plan on just hauling that. But sludge hauling is something that can get pretty costly. It's something that you really want to think about sometimes, depending on your location. This last one that I'll talk about was an electronics facility. They had metals treatment, metals removal systems. This electronics facility was, I'm not familiar with how that all goes, but they had multiple lines treating various streams within the plant that had different target metals that they were trying to remove. What that meant is they wanted for each one of those lines a dedicated press system to do the sludge dewatering. And so what we ended up going with was a filter press, just because you can get, in this case, I think it was 5 filter presses. 5 filter presses that are going to handle the sludge that you want on a much lower cost than if you're going to do the 5 belt presses or 5 centrifuges or 5 something else. So it's just, and it then, you know, you're getting a really dry cake, so that high metals waste is usually pretty hard to haul off. So it's a nice low volume, low weight cake that you're generating. Let's see, yeah, that's it. So secondary treatment, I think John did already a pretty good job of going through everything here. Just to repeat, removing soluble organics. So you're going to remove soluble COD, soluble BOD. It's going to come after some form of pre-treatment, unless you're, you know, making just a fluid product that's, you know, like a beverage facility or something like that, where you don't have a lot of solids and it is all soluble BOD, COD that you're trying to remove. Let's see. Direct discharge or POTW limits is usually the driver for why an industrial facility is going to do this. I get we do a lot of projects or a lot of quotes for systems to reduce surcharges, and in most cases those just don't go anywhere. There's just not a big enough driver yet. I think in the years and decades to come that will most likely change. But right now it's just not a big enough driver to justify a full biological treatment plant, unless if you're trying to put it direct to a stream or river, or you're trying to go to your POTW tells you have to do that.
So your picture there looks like there's a clarifier with some packing in there, or what is the?
So that's a fine bubble aeration system.
Oh.
Yeah. So that you probably rarely ever get the chance to see that, because most of the time there's biological material. This was on commissioning, so you can actually see the air grid in there.
Oh, okay.
I think this is actually so we work with Westech, and I think this is actually one of their biosystems that does have a clarifier in the center as well. So we've already talked a lot about the activated sludge systems and conventional systems. Figured it'd be worthwhile just touching quickly on more advanced systems that are out there that have been getting used more frequently recently. They're MBBRs, which is a moving bed bioreactor. What that is I call it bug condos, and that's a really great name. But they're essentially like Lego pieces that let the biological material build up on that plastic. And so it's actually a fixed film biological growth rather than a suspended growth biology. What that does is it reduces your footprint by some amount. You can typically put a higher loading into that system. And then they also, because that fixed film is a slower growing biological material, it typically stands up better to shock loading than activated sludge system, just because you retain some of the MBBR. People say it has a memory of the shock loadings that it's seen in the past. So if you put something down the drain that's really not great, a lot of times there's still that biological material that can handle it a little bit better. And like we said, it does have a smaller footprint. The fixed film media or the fixed film biological growth does not have great settling characteristics generally. So that is one area where you do a lot of times see a DAF following an MBBR rather than a clarifier. Not always the case, but in a lot of cases that's the chosen separation device. So then on MBR, which is a membrane bioreactor, they'll, like John mentioned, they'll use a standard activated sludge aeration tank. And then after that, for the separation device, you'll use a membrane system. Typically, it's an ultrafiltration membrane. Here's one type where the strands, so you can see the straws that are standing on end, and they extend down about 6 feet or so to the bottom. The water gets pulled in through the straw, and the biological material gets retained on the outside here. So you're generating a really high quality effluent stream, really good if you're looking at reuse. And the other benefit is that then you can increase the MLSS of your activated sludge system. So you're able to do a lot more aggressive treatment of that waste. So you can usually put a lot more BOD into that system, get a lot better treatment on a smaller footprint. So, yeah. Anaerobic treatment, I've already talked a lot about this. Generates a biogas stream, reduces your sludge generation, lower power consumption compared to an aerobic system, and it can handle the higher inlet BOD concentrations. This is just an interesting piece of equipment, I think, from anaerobic. So you saw the flat membrane covers on some of the other pictures. This is a biogas holder, so this can go on top of anaerobic system, and it actually is there to just hold and provide some storage for the biogas for a period of time, rather than needing to immediately use it or flare it off. So it's just a way to more effectively use your biogas over a period of time. Again, this is just kind of the things to think about and look at. I'm not going to go through all of these in nitty-gritty detail, but I think the key ones are if you have nitrogen, phosphorus removal, anaerobic's not going to be your one. If you have high inlet BOD, anaerobic is something to consider. If you need really low effluent BOD, you want to think about one of the activated sludge conventional aerobic treatment systems. This will be my last example, and it's pretty quick, but this is for a grain processing facility, super landlocked. It's dead in the middle of a town. On the north side, they're bordered by a railroad that they can't move, and I think on the south side, they are up against a state park. So there's really no chance of them getting any additional land. They were stuck. So they had gone through, common theme here, they had gone through a number of plant expansions and were looking to do the next one and realized they needed to do something with the biological system. And again, they had no room to go. What they ended up deciding to do was install an MBR system. It allowed them to get rid of the secondary clarifier. And then it also allowed them to, I think they doubled the MLSS of the aerobic system, which then gives them a much higher treatment rate, and they can put a lot more flow through the system than you would normally be able to. So again, we did the full conversion of the secondary clarifier into membrane system, and now they're generating a fairly nice effluent stream that's fairly ready for reuse. At this point, I don't think there is.